Welcome to the AI-generated UWS CCT's research podcast from the University of the West of Scotland Creative Computing Technologies Research Group. We're here today to unpack some really interesting new work. It's a paper titled A Web-Based Virtual Tour System for Cultural Heritage, the case study of the Cutty Sark.
That's right. It's by Marco Gilardi, Raymond Holder, and Thanos Kokkiniotis. And what we're looking at is essentially a new system they've developed for creating virtual tours, for museums, historic sites. They use the famous Cutty Sark ship as their main example, their test case.
Right, the Cutty Sark. And it sounds like they're really tackling a significant challenge here, something many cultural places face when they think about virtual experiences, especially the more advanced ones like 3D or VR. What's the kind of core problem they identified?
Well, think about how virtual tours work now. They've definitely become more common, especially, recently. And for the museums and sites themselves, they can be great. A good promotional tool, maybe even encourage folks to visit in person. Plus, they change the experience, right? From just looking passively to actually exploring and learning interactively.
Yeah, making history feel a bit more hands-on, even virtually.
Exactly. And we've seen this big shift towards bring your own device, DYOD, in heritage settings. You scan a QR code maybe with your own phone, and boom, you've got a guide or extra info right there. It cuts hardware costs for the institution, gives you control over your tour, on-demand info, and you even get a kind of virtual souvenir.
That BYOD aspect seems really important for making things work on a larger scale, doesn't it?
Oh, absolutely crucial. Now, imagine pushing that further, really immersive stuff, maybe full 3D environments, maybe even proper VR headsets. The potential there is massive, particularly thinking about accessibility. You could let someone see areas that are normally closed off, or visit from halfway across the world, or navigate spaces that might be, physically difficult for some visitors, perhaps those with disabilities.
Okay, that does sound pretty amazing. So what's the difficulty? Where's the barrier?
The barrier, or the challenge, is that many of those really high-end immersive VR experiences, they often need specific, expensive hardware that only works on-site. And that means a big investment for the museum or heritage site, buying the gear, finding dedicated space for it, plus the often very high development costs, which are usually tied to that specific hardware. It just puts it out of reach for a lot of maybe smaller or less well-funded places.
Okay. So the paper is asking, how do we get those really engaging, immersive experiences, but make them, easier and cheaper for institutions to actually create and roll out?
And simply for visitors to access too. Precisely. That's the gap they're aiming to bridge with their proposed system.
And the key to their solution is that it's web-based. That's the main thing.
That's the fundamental idea, yes. They've built a three-dimensional virtual tour system using web technologies, specifically things called Web3D and WebXR.
Okay, hang on. Web3D, WebXR, maybe break that down a bit. For listeners who aren't deep into web tech, what does that mean practically?
Sure. Think of them as the tools that let you put complex 3D graphics and even virtual reality experiences directly into a standard web browser. So instead of needing to download a special app or install specific software, you could potentially just go to a website address and experience the tour.
Got it. So building it on the web, how does that actually reduce the effort and costs compared to, say, making separate native apps for phones, computers, etc.?
Well, a big advantage of a web-based approach is often that you develop one main system. And that single system can then hopefully be accessed across lots of different devices, different operating systems, just using the browser that's already there. You avoid having to build a separate Windows version, a Mac version, an iOS app, an Android app.
Right, so it's aiming for maximum reach for the user and minimum pain financially and technically for the institution.
That's the goal. The real innovation they're driving at is this idea of creating a virtual tour from a single code base that works on your phone, works on your desktop, and works in a VR headset. This kind of multi-platform web-first approach, especially if you tie it into that BYOD trend, it just massively lowers the barrier to entry. The financial hurdle for cultural sites wanting to offer these, richer 3D or VR tours.
So the paper zeroes in on that problem, making these advanced virtual tours affordable and widely accessible. And their answer is this web-based system that works everywhere.
That's the core idea. And the potential impact is, enabling many more institutions, big and small, to offer these kinds of engaging, accessible experiences and reaching a much broader, more diverse audience as a result.
And they didn't just talk about it, they actually built it. Let's get into the case study. The Cutty Sark. Give us a bit of context on the ship itself.
Right, the Cutty Sark. It's a very famous ship, a British clipper built way back in 1869, in Scotland, actually.
Yeah.
Famous for its speed, especially in the tea trade. Now it's preserved as a museum ship in Greenwich, London, a major historical landmark.
And why did the Cutty Sark need this specific virtual tour? Was there a particular reason?
Yes, there was. Back in 2024, part of this ship known as the Liverpool House, this includes areas like the master's cabin, the saloon, it had to be closed for some essential maintenance work. So Royal Greenwich Museums wanted a way for visitors to still explore and understand these key spaces, even while they were physically off limits. That's why they commissioned this virtual tour.
Ah, okay. Very practical, real-world need. So what was the tour like for someone using it?
You could get to it in a few ways. On-site, scanning QR codes, or through the Smartify app many museums use, or just online from home. It covers 9 specific points or stops within that Liverpool House area, and it starts you off with a kind of bird's-eye view, a home stop, to help you get your bearings first.
And from there, you can jump between the different rooms.
Exactly. You navigate between these predefined stops.
Yeah.
They also added some nice little details to make it more engaging animations of signal flags fluttering, the ship's wheel turning, and apparently 3 animated border collies based on dogs known to have been on the ship.
Border collies, that's a lovely historical detail. They also mentioned a twinning camera effect for movement. What's that?
Right. So instead of just instantly appearing at the next spot when you click, the camera smoothly travels. It sort of glides from your current view to the new one.
Huh.
It makes the navigation feel more fluid, more connected, less like a sudden jump cut.
And critically, thinking about accessibility again, the information came in both audio and text.
Absolutely. That was a key design choice. It ensures people who might have hearing difficulties or perhaps dyslexia can still fully access all the historical information being presented.
Now, creating the 3D model for the inside of an old, complex ship like that sounds challenging. How did they actually build and then optimize these models?
Well, they started with data capture, using 360-degree photography, drone footage for the outside, and detailed 3D scanning, using a specific camera, an Intel RealSense LiDAR L515.
Okay, so gathering as much real-world data as possible.
Precisely. But then, for the interior spaces, the Liverpool House, where accuracy was really important, they made a conscious decision. They decided not to just rely on automatic 3D reconstruction from the scans. Instead, they used that detailed scan data more as a reference guide to manually model the spaces using 3D software, specifically Blender.
Manually modeling. That sounds like a lot more effort than just letting the software figure it out. Why go that route?
Because automatic reconstruction, while powerful, can sometimes produce models with glitches or messy geometry. They call them artifacts. Things like slightly bumpy walls that should be smooth or just odd-looking surfaces up close. By modeling it manually, using the scans as a blueprint, they could ensure much cleaner, more accurate geometry for those really important interior views. Now, for the external environment around the ship, where super high detail wasn't the priority, they did use automatic methods, reconstructing it from drone footage and software called reality capture.
Okay, so manual for the bits you really look at closely, automatic for the surroundings. Makes sense. Once they had these models, getting them to run well on everything from a phone to a VR headset, that must have involved some serious optimization work.
It certainly did. They took quite a few steps. Things like reducing the polygon count, basically simplifying the 3D shapes without losing too much detail. Reducing the quality of the textures, those are the image files wrapped around the models, to give them color and detail. And generating multiple versions of textures at different resolutions, like 1K, 2K, 4K. So a less powerful device could load a lower res version faster. A particularly clever trick was baking shadows directly into these textures. That means the device doesn't have to calculate complex lighting and shadows in real time, which saves a lot of processing power.
Baking shadows, yeah, that's a common technique in games too, helps performance a lot. What tools were they using for this modeling and texture work?
Primarily Blender for the 3D modeling itself, Photoshop for working on the textures, and reality capture for that external reconstruction part.
And they had specific technical targets in mind, right? Especially for making it run on mobile phones.
Yes, they did empirical testing,
Yeah.
basically trying it out on different devices. They determined that to get smooth performance on most mobiles, the whole 3D scene needed to stay under 70,000 polygons, and the total download size had to be kept under 20 megabytes, which, for a detailed 3D environment, is actually quite tight.
Wow, yeah, that really highlights the technical constraints they were working under. Okay, so how does the user interface, the controls, adapt? How does it look different on a phone versus desktop versus VR?
The design is what they call responsive. So on a phone or a computer screen, you typically see control bars, usually at the top and bottom. The top bar might have links to quickly jump between the different tour stops, the different locations. The bottom bar usually shows the name of the spot you're in, gives you controls for the audio narration, play, pause, and a button to show or hide the text transcript.
Okay, fairly standard and functional for screen-based viewing. What about putting on a VR headset?
Right, for VR, you'd usually open the tour link in the web browser inside the headset itself. There's typically a button you press within the web page to explicitly enter VR mode. Once you do that, the regular on-screen UI, those top and bottom bars, they disappear. You get a fully immersive view. Then you use the VR controllers, or maybe hand tracking if the headset supports it, to interact. Movement is often done either by teleporting, pointing where you want to go, and instantly jumping there, or if you have enough physical room, by actually walking around a bit in the real world.
And this was designed to work with the common standalone VR headsets out there.
Yes. The aim was compatibility with popular ones like the MetaQuest headsets,
Yeah.
and likely newer ones like Apple Vision Pro 2 via their built-in web browsers.
Now, one of the most interesting technical aspects mentioned in the paper is this idea of a no-code approach, making it easy for non-programmers to create new tours with this system. How does that work?
It's built using what they describe as a data-first design, and the whole thing is driven by a single configuration file, specifically a JSON file.
A JSON file. Okay, for someone not familiar, what's a simple way to think about that?
Imagine like a master recipe card, or maybe a very detailed, very structured shopping list for the entire virtual tour. It's essentially a text file, but organized in a very specific way. It contains all the key information. The file paths, telling the system where to find the 3D models and the textures, specific settings for VR mode, and then for every single stop in the tour. It lists its unique ID, the name that appears on screen, the exact camera position and angle for that viewpoint, the pass to the right audio file for narration, and the actual text content for the transcript.
Wow, so the content definition is the configuration.
Pretty much. The different parts of the system, the user interface module, the 3D graphics engine using WebGL, they're designed to just read this JSON file. The UI looks at the list of stops defined in the JSON and automatically creates the navigation buttons. The 3D engine reads, the camera coordinates, the model paths, everything it needs directly from that file.
That sounds incredibly powerful. So if a museum wanted to use this system to create a tour of a completely different exhibit, they wouldn't necessarily need a software developer.
That's the massive advantage. Someone creating a new tour or just wanting to update the information or maybe change the appearance slightly, they don't need to write or modify any programming code. They just need to edit the information within this structured JSON file, create new entries for new stops, update text, point to new audio files.
That really does lower the technical bar significantly for heritage institutions, doesn't it?
It absolutely does. And the system's design is modular too. That JSON file can even turn features on or off. Like you can enable or disable VR support entirely, or define the specific floor area where teleportation is allowed in VR, all just by changing settings in that one data file.
That's genuinely quite innovative for making this kind of tech more democratic, spreading it beyond just the big players. Okay, so what happened when they actually deployed this at the Cutty Sark? What were the results?
Well, the deployment was considered a success. The tour clocked up over 10,000 visits.
Yeah. Over 10,000? That's pretty good engagement. How did those visits break down by the type of device people were using?
The split was about 57% on mobile devices, around 40% on desktop computers, and then roughly 3% using VR headsets. And the authors mentioned this distribution kind of matched what they expected, because a lot of the promotion was done right there on site with QR codes and through the Smartify app, both of which naturally lead to more mobile usage.
Makes sense. And what about feedback from visitors? Was it positive?
Yes, they reported receiving positive feedback generally. And they specifically noted that staff at the Cutty Sark recorded hearing appreciation from visitors who use wheelchairs.
Ah, that specific anecdotal feedback links directly back to one of the main motivations, right? Improving accessibility.
Yeah.
So how do these results connect to the paper's bigger arguments?
Well, the fact that it was successfully deployed and used across all these different device types, mobile, desktop, VR, it validates their core technical approach. It shows the web-based system can reach a wide audience effectively. And that feedback from wheelchair users, even though it's anecdotal and not a formal study, it provides a real-world hint that the system could genuinely help provide access to places like the Liverpool House, which might otherwise be impossible for some people to experience fully.
They also mentioned thinking about the financial side, how institutions might value a tour like this.
Yeah, they suggested looking at it maybe with a metric like cost per visit or cost per download, similar to how you might evaluate a mobile app's reach. But they also argue that for cultural heritage, it's not just about direct financial return. It's also about raising awareness, engaging people with the site's history, and reaching a large online audience effectively lowers that cost per impression.
And the way the system delivers information, the visuals, the audio guide, the text transcript, that also fits with what research says works best in these virtual environments.
It does. Existing research supports using multiple modes, visual, text, audio, because people learn and engage differently. And also, the fact that visitors can generally roam freely between stops, driven by their own curiosity, rather than being forced down a single linear path, that aligns with preferred ways visitors like to explore, which their system facilitates.
Okay, it sounds like a really well thought out technical solution that definitely hits the mark on making these tours more achievable and accessible. But the paper was also upfront about limitations and areas for future work.
Yes, absolutely. They're clear that this is a starting point, a foundation. They mentioned that while the current system works well for this kind of guided exploration between fixed points, a more comprehensive system for actual interaction within the VR environment is something that's still under development.
And what about that 3D modeling process? You mentioned how much manual effort went into the Cutty Sark model.
Right. They identified a need for a more sophisticated, maybe automated, dynamic system for handling multi-resolution models, something that could potentially streamline that whole process of creating and optimizing the 3D meshes, reducing some of that intensive manual work they had to do for this case study.
And probably the most significant limitation they pointed out, thinking about the impact of the tour.
Yes, this is really key. They explicitly state the lack of a rigorous empirical evaluation of the tour's actual impact.
Right.
So while they have the visitor numbers and that positive anecdotal feedback, they stress that future research really needs to try and quantify the real-world effects, especially focusing on accessibility, understanding how much benefit visitors with physical disabilities actually gained from using the tour to see otherwise inaccessible areas like the Liverpool House.
Got it. So the technology demonstrably works, it gets used, but the next crucial step is properly measuring the tangible benefits it delivers, particularly for those who rely on its accessibility features the most.
Exactly. Proving and quantifying that real-world value, that's the next challenge.
Well, this research certainly presents a very practical web-based system. Developed by researchers at the University of the West of Scotland alongside Smartify, it seems to make these sophisticated multi-device virtual tours much more attainable for institutions and definitely more accessible for visitors. It really feels like it's about lowering those barriers, using creative computing to open up heritage in new ways.
Yeah, it's genuinely exciting to see how technology like this can, unlock our cultural sites.
It really makes you think, doesn't it? Looking beyond just seeing places you couldn't physically visit, what are the most truly meaningful ways that technology like this can actually deepen our connection, our understanding of history and culture?
That's a great question to ponder as these tools continue to develop and become more widespread.
Thank you for joining us for this discussion today.